All right. Hello, folks, and welcome to another edition of CrossHack. We are continuing our series here on our Crossplane and Cluster API integration. This is part 4. You can see in the live stream description the past few streams that we've had, and if you want to take a look back at those, you can see them there. Definitely feel free to drop your name in the chat and let us know where you're joining from. We're just going to be continuing that work today, hopefully to get Cluster API and Crossplane integrated so that Crossplane can kind of serve as the engine for Cluster API. I am using OBS again today, so you should have a little bit better of a aesthetic stream here. But I did kind of get it together a little bit haphazardly. So definitely drop a note in the chat or hit me up on Slack, in either Crossplane Slack or Kubernetes Slack, and let me know if you are having issues. But let's go ahead and jump right into it. All right. Gonna open up a new window here. And we'll start off just like we have every week so far, or every stream so far, and hop over to our provider GCP issue where we're tracking all this work that we're doing. And I'll also need to make sure that I'm on the right branch here. I made some updates to provider GCP recently. Let's see what branch. Oh, this is in the back off branch. So let's check out CAPI types. So we're going to have to do a rebase to make sure we're up to date here. And I'm going to go ahead and go out a few levels here to our cluster API provider GCP. And sorry, just checking a notification real quick. All right, cluster API provider GCP, and what branch are we on here? Okay, so last time we were on, we went ahead and found an issue when we were trying to run cluster API provider GCP locally, and that has actually been fixed now. And today is going to be the day where I add a bookmark for cluster API provider GCP because I keep having to do this. Let's see, here it is. I thought I had added one, but I guess not. All right, let's add a page. CAPI, let's see, I think a K-SIGs, CAPI GCP. All right, now we have a good link to that. So last time we were having issues installing the CRDs because of a recent pull request, and we were able to get that fixed. So thank you to Jason and Carlos who reviewed this. But essentially, we just need to make the key of the metadata field required. So this has been merged, but I want to go ahead and make sure we're up to date locally. So let's try that out. Hopefully we don't have any conflicts. Let's see. Okay, looks good. And well, we can just stay on master for now. All right. What do we have modified here? Oh, our customization. Yeah, that was just to get cluster API provider GCP installed. All right. So let's check where we were at with our CAPI types here. Let's see. Get log. Let's see. Yeah, we have this temp commit. So I'm going to go ahead and roll that back. All right, here we go. So we had implemented our router, the GCP cloud router, as well as the health check. And you can view those past streams if you want to take a look at that. So what's left to do are, let's see, we did health check, router. We weren't sure about that router NAT, but we're going to not worry about that for now. So we have these left, which looks a little bit daunting, but it is actually probably going to go pretty fast. And we already showed that we have create and delete working for health check and router. So we're going to push along before doing update on those, just because we want to try and get to a working POC as fast as possible. And it looks like that this backend service, once again, we modified health check service to health check last time. And so I'm guessing, yeah, let's see, scope network, API server, health check. Excuse me. All right. And this is the health check that we created. So we are going to, let's see, network, API server, health check. Let's pull up the backend service here. And this is a little bit slow. I'm going to go ahead and open up our editor here. Also, if sound or my video is kind of weird, I just put together this kind of like background and configuration right before this. I don't love how the video of me overlaps on the screen. And probably most people don't want to look at me anyway, so I can definitely make that smaller. Yeah, feel free to let me know if you're having any issues viewing it. All right. So this is just our Prometheus config here that I was using for something else. We don't have to worry about this or this. All right. So last time, like I said, we worked on the health check. So let's go ahead and create our backend service, I believe it's called. Let me double check that though and make sure that we have the right type we're using here. So backend service, is that what it's using? Yeah, right here. And I believe we checked this out last time. It doesn't look like there's too much in here. Let's see, failover policy. Some of these appear to be output only. And then health checks, a list of URLs to health checks. So this is, we're going to create that health check and then have a reference to it. So we'll look a little bit about how reference resolution looks like, which we saw a little bit in the router. These are all output only. Okay, so it's not tiny by any means, but not way too much. So let's go ahead and get started on that. I'm just going to go ahead and copy over the health check types into the backend service here. And we're going to see a lot of conflicts, right? Because we have health check defined twice. So all of these nested types, I'm going to go ahead and get rid of. So up to the observation. And then let's just do a find and replace on all of these health checks here. And we will call them backend service. Also, let me know if I need to make the screen a little bit bigger. Happy to do that as well. In fact, I'm just going to go ahead and anticipate that that needs to happen here. And we'll make this a little bit nicer. All right. And backend service. These are inaccurate, but we'll go ahead and copy over here. Let's get rid of all of these and all of these fields. And let's check again what Cluster API is actually using. So it's using a load balancing scheme, port name, protocol, timeout, and health check. And then it looks like it also has a reference to the instance groups. So that might have to be a to-do here to go ahead and implement that. Let's see, res.backends. So backends must be a nested type in here, I'm assuming. Potentially. Yeah, backends. List of backends that serve this backend service. Cool. Awesome. All right, so I'm going to do like I did last time and go ahead and jump over here. And we'll start by just copying all of this over. Looks good. and we'll drop it in here. So a lot of these are going to be unhappy at first. And then some of these we want to go ahead and move over to our output only here. Oh, it looks like I copied over too much. Let's see. Let me undo that real quick. All right, so we don't want this aggregated list, nor this. Let me make sure that that's everything I copied. Okay, looks good. So I'm going to go back down to the bottom here, and we'll get rid of these fields, which we don't need to be in the spec, because they're more imperative fields than anything. But we do need to copy over our, let's see, our output only first. Looks good. Let's see, is there any other output only? Here we go, ID and kind. Interesting that I think kind was the one in the health check that said, and we're going to go ahead and delete name here, which once again, we use the external name annotation in Crossplane to name things. But I believe it was kind in the health check that I thought was output only, but apparently wasn't. And here it does appear to actually be output only. Okay. We'll go ahead and fix this up. Int 64. And it doesn't like that it's ID. There we go. All right, what else do we have here? So we're gonna have to get these nested structs, but I believe, okay, and this network is going to be, also that's interesting. This network is probably going to be a reference. This field can only be specified when the load balancing scheme is set to internal. So we're not actually gonna use this, but we need to support it. And so we'll go ahead and do that actually. So the network reference is just gonna look just like the router reference to the network as well. So that was easy. And we'll have to come back through here and check which one of these are actually output only. Let's see. Doesn't like this once again. So first thing we need to copy over is this backend type. So let's go ahead and grab that struct here. Hope it's not too many nested fields. And it's not small. All right. And if you didn't tune in to the other streams, you'll recognize here that this is quite a lot more of the fields than are supported in Cluster API, right? For these here, and in fact, these are mostly hard coded or they're from another resource. The beauty about what we're doing here with Crossplane and Cluster API is that Cluster API is really just saying, okay, we're doing the bare minimum here to get the infrastructure up, because what we really have expertise in, and this is what is in the core Cluster API controllers, is installing Kubernetes onto this infrastructure and managing Kubernetes there. And as Crossplane, we say, we don't have that expertise, so we'd prefer to actually give you full configurability of this infrastructure and then expose this in an abstraction. So all of these types here are actually under the GCPCluster type. And I apologize if you've listened to some of the other streams. Let's see, Kubernetes SIGs. I've been over this quite a few times now, but I think it's worth rehashing regularly because it is really the motivation for doing this. But basically, all those different types, all these types in the issue that we wrote down here are all represented by this GCPCluster type. So this controller for GCP cluster knows how to manage all these different types. With Crossplane, instead, we're saying we will create this GCP cluster type using an XRD, which is our abstraction mechanism. And behind the scenes, we will fulfill that with our granular resources. So that means that someone can come along and say, you know, I don't want my backend service timeout seconds to be this. I'll go ahead and modify that. And I can still run Cluster API in the exact same configuration and just have my kind of different things subbed out there. So essentially, you get granularity in the level of abstraction that you want, which is really valuable, in my opinion. All right. One moment. All right. So we'll once again remove these from the backend struct here, backend service struct. And most of these look like they're pretty much just native types. Awesome. So all right. What's next? So that one was pretty easy to copy over. So even though we had a nested struct there, it wasn't a big burden because there wasn't any nested types in that nested type. So next we need the backend service CDN policy struct, which I'm guessing is going to be quite small. Yep, just a couple of fields here. Let's go ahead and copy that over. And we might, if we have time for it today, actually, oh, this has another nested field in it, so we'll need to get this cache key policy. We might actually give it a try using these resources and just leaving out some of them if necessary. Ooh, this is kind of a large nested struct here, unfortunately. Backend service CDN policy. Remove these. Let's see, was there anything? Nothing nested in here though, so not too bad. And once again, I'll come back through here and fix all of these after the stream. All right, so we've got our CDN policy, circuit breakers. That's not going to work. I'm going to have to get it from this struct. Here we go. It's actually performing pretty well. I think that OBS doesn't hurt the bandwidth as much. Also, this looks very similar to the backends struct earlier. But I don't think this hurts the bandwidth quite as bad as using Zoom does, which is kind of surprising in some ways. All right. We'll get rid of these. Okay. And most of these are probably all optional, which we like to use pointer types for. But we can follow up with that down the road. All right. Connection draining. And if there's anything in particular y'all want demonstrated during the stream, definitely feel free to drop that in the chat, and I'll make sure to prioritize that. This is all a little bit tedious, I know. So it looks like we forgot to remove our fields here. This is all a little bit tedious, and I'm happy to do something specific if that's of interest to folks on the stream, and do some of the other work outside of it. All right. Next one, consistent hash load balancer settings. A lot of these are conditional on the on the type of backend service it appears, or the load balancing scheme of it, if you will. And Muvafiq, who's also a maintainer on Crossplane, has been doing some work around validation webhooks and stuff for these providers in Crossplane. And what's really cool about the work that Muvafiq is doing is it takes advantage of the fact that we have our own package manager and can control the life cycle of things that are installed. So that's really valuable because when you're creating webhooks and things like that, you have to manage certificates, make sure they're distributed appropriately, that sort of thing. And we can just actually do all of that for your provider when it's installed, making it much easier for both consumers of the provider and provider authors. So I would think this would be a, let's see how duration works under the hood here. All right. Nice. Okay, so we still have a few fields to fix up here. Backend failover policy is the next one. Or backend service failover policy. Once again, not too big here. Wow, it takes a lot of components to spin up a Kubernetes cluster. And as a nice reminder, if you'd like, with provider GCP today, you can go ahead and just spin up a GK cluster. But some folks have use cases, right, for running Kubernetes themselves on VMs and that sort of thing. And that's what cluster-api does a really great job of enabling. All right. And we'll drop this in. This is the IAP. Strip these off. Backend service log config and outlier detection. All right, and this just has 2 fields, which is nice. I keep getting a little distracted because there's a Kubernetes alpha release. I think it's an alpha going on right now that Taylor is running and doing a great job of. So make sure to thank Taylor when that comes out later today. Outlier detection. All right, and this is the last one, I think. Yep. And we'll strip these off once again. All right, so that looks good. We need to register. We also need to set up the referencers, and we're going to need the health check referencers as well. So let me copy this over. Health check. Backend service. And then once we actually register this, it's not going to like it at first because we haven't generated the deep copy methods yet. All right. But besides that, it should be good to go. So we can go ahead and run make generate. Let's see here. Unsupported type float 64. All right, so we have a few of those in there. Let's find those. Float 64. Can't remember. I think it's what's the name of the field used for, let's see, Cube Builder book. I can never remember the name of the field used for floats. Yeah, floating point resource.quantity. There we go. All right, float 64, and we're going to replace all of those with resource dot quantity. Let's see if it finds that automatically. Looks like it did. Oh yeah, and I don't know why it says this is an error, but for a moment it does usually. Okay, let's try that. Cool. Let me respond to something real quick. All right. Just following up on a few messages here. All right. So we have that all squared away. Let's make sure the generation. Oh, no, we still have it. Unknown type resource.quantity. I wonder if this is not the right package. Let's see. I haven't used this in a little bit. Resource dot quantity. Let's see. I guess it's not used in the example at all. It might be. Unknown type resource dot quantity. I know we've used this somewhere. Let's see if we can find it over here. No. Maybe in Crossplane itself. Let's see. Why did this flag it? I wonder if we just have the wrong import type here. What type was this in? Maybe the core trait types. Well, actually, I can just take a look back. Let's see. Why doesn't it like this? Also, GitHub has been hanging up on me a little bit recently. Let's see here. Let's see, core workload types. I thought that's what we were looking at. It could have gotten updated after that. Core trait types, core types. And let's see, where is core workload types? Here we go. Resource, yeah, so I think that the package that it pulled down here is not the one that we want. Yeah, we want the API machinery one. Cool. All right. Awesome. Okay, looks good. And let's go ahead and see if we can knock out, and let's see if it likes it now. It should. Let's see. Missing method deep copy. No, I think that exists now. Okay, I'm going to go ahead and resolve the references of the backend service here, just for the network. Let's see. Backend service of this. Let's see, backend service. And okay, so all of these are going to look pretty much the exact same. Still says it doesn't like that. Did the make generate worked okay? Anyway, we can come back to that. Okay, so this, we're going to use the same network selector here. What I want to note to do #dan resolve references to health check and instance group. Okay. And let's go ahead and move on to the next one here. We're going to try and fly through these. Okay, target TCP proxy, and it appears to reference the backend service. Let's try this, target TCP proxy. Okay, this looks very minimal in how it's being used here, at least. We'll see how minimal it is actually with GCP. Copy this. Was it target TCP service type.go? Was it service? Let's see. TCP proxy. TCP proxy type. And we'll do the same thing here where I'm going to just clear out everything up until, oops. Let's see, backend service parameters. Goodbye. And then we'll look up backend service. And we will replace that with target TCP proxy. All right, looks good so far. And yep, as expected, this is a very small resource, which is good to see. And some of these are output only anyway. So we'll go ahead and do this. Once again, I will follow up with fixing all the comments and that sort of thing. Service URL, let's see, this is output only. Kind, ID, and creation timestamp are all output only, and name we're going to handle with external annotation. And creation timestamp, last one. All right. Note to self to circle back to make this an enum. All right, and so what we need to do here is make this so the target TCP proxy can reference the backend service here. And so, well, first thing we need to do is get some of these and bring them over. And these are going to be service, not network. Service. service ref, service selector, all right. Should have copied these at the same time. All right, service ref, service selector, reference to a backend service. References a, I'm not sure what type of value it actually resolves to here. URI to the network, yeah, okay. Oh, service redeclared. So it calls it a URL. Description, that's fine. All this looks good. And let's go ahead and register this. All right. And once again, we're going to need to register this and then generate again. Doesn't like the lowercase TCP. We'll probably adjust that later. And then we want to have the, so target TCP. I'm going to go ahead and uppercase this one. Resolve references, and once again, target TCP proxy. All right. And so these all need to be service. Spec.provider service. And this is going to be, we actually don't even need that because it's in the same package here. And we'll do service, oh, backend service list. That's the issue. So those are right. For provider, service, service ref. So in the reference, it's called a service, but the resource type is called backend service. This can go away. This is the only reference it has. But what we need to do, so we're using this network URL, which I actually wonder, so we're going to take the self link and compute URI. So this is actually going to work because I believe that this URI prefix is going to be the same as the self link. So we should probably, oh wait, but it has to be, I see, we have to pass in the field here. So we need to move this over, put this in referencers. I'll put it at the top. We'll say router, no, sorry, backend service URL, a backend service. And we may want to copy this over, but we'll just do this for now. And perfect. Okay, so that's already ready. Let's do backend service URL. And this is what we want to use for it does take a, so this would actually, I believe, still work for either the network, right? Cause it's, oh no, it checks that it's a network. Okay. Did we actually update that? Yeah. Perfect. So that's good. That would be not great if we weren't checking that it was the right type. All right, let's run our make generate again. So that one was much nicer than the previous one. So we need a forwarding rule which references global address, which is a v1 beta 1 type we already support. And it patches from this load balancer forwarding port, which we can talk about that later. Forwarding rule spec. Okay, so there's some stuff in here. I wouldn't be surprised if it is relatively verbose. Let's see if this worked here. Missing method get condition. Man, I always can't stand this because it doesn't like the errors here, so it won't generate because they're in the same package. So let's see if it works here. Well, so I should probably check the chat. Haven't done that at all. It looks like that no one's posting anything, so that's fine. All right. So that ran successfully. So now this should be happy, although I'm guessing it's not going to be because it's not really liking it today. Let's see if reopening it works. Looks good. Okay, next we have forwarding rule types. And let's grab this backend service. Or actually, I'm going to use the TCP proxy because it was smaller. And we will start with getting rid of this again. Did this one have the reference the back? No, I think this actually references the TCP proxy. So let's find this. And we'll replace all of these with forwarding rule. All right, let's see how bad it is. Okay, IP address, IP protocol. So no nested types yet. This metadata filter we'll have to copy over. So pretty good. Target HTTPS proxy. So there's some types that we are not going to have right off the bat, but we will support them soon. All right, forwarding rule parameters. So I think the only one was the metadata filter potentially. So we're going to need references to the subnetwork. I think probably the target is the forwarded traffic must be of a type appropriate to the target object. Okay. Let's see how target API server target proxy. So I think this is the TCP proxy. Load balancer scheme protocol. Got it. Okay. So once we have all of these set up, and I'll go ahead and remove name here, and all right, so network ref ports, it's just a slice of strings, region, output only, self-link, output only. Okay, so let's go ahead and move our output only fields. So service name, self-link, region, port range, network tier, network, metadata filter. Let's see, output only here. All right. looks good. Metadata filter. ID is output only. I'm going to go ahead and fix this. IP version. ID, need to make that int64. Description, okay, so output only. All right, so I believe that the creation timestamp is the last output only. Backend service, okay, nice. So this is going to be a reference to the backend service. So let me copy this over. And so the total things that it can reference is the, let's see, the proxy. Let's live in the same region. Okay, so it can reference multiple. Interesting. So this can reference multiple different types. I'm not sure if we have an example of this elsewhere. So we'll have to look at that. I mean, for this first iteration, all we care about is patching or resolving from the TCP proxy type, but that could change over time. Okay, so we're going to need subnetwork ref, network ref, and okay, fingerprint's probably going to go in output only. Backend service ref. All right, so I'm going to copy over once again some of these. Well, we'll go ahead and do it for subnetwork. Let's see. Network. Subnetwork. Oh. That's tough. All right. We'll forget that for a second. Subnetwork ref. Subnetwork selector. And all right. Looks good. Let's go up to network. And this one is much easier. And last one is going to be backend service. Did the target TCP, we had the service selectors here. So let me go ahead and fix these up. No. Backend service, backend service. Oh, and it still calls it a, wait. What does it call it? Forwarding rule. I'm guessing it calls it actual backend service. Yeah. All right. Awesome. And that metadata filter is the last thing here. And let's see if it actually, so it looks like we don't actually reference the network here. use the IP address and the target proxy, which is the thing that we haven't actually built the network ref for. All right. Oh, wow. This is somewhat large. Oh, no. Okay, just a few fields. Observation. Let's move these down. Filter, label, match. Okay, there's a couple more. This is just a small one. All right. Okay, and the thing that we really need to do, yeah, is the target here. We need to support target. No, I do not want the new version of Go, please. It's behaving well today. Target. Let's see. Retrieves its URI. Okay, that's probably fine. And we're gonna have to go back and put optional and immutable on all of these. But I want to, once we get a few more of these implemented, which we just have 2 more, I want to start building out our composition so we can look at what that's going to look like. Let me take a look at a message real quick. All right. So we really need to add our referencers here, though. And target TCP proxy. This is for forwarding rule. And it's not going to like it at first. Okay, so we can reuse this backend service here. Once again, we don't actually even reference this. In the cluster API configuration that we're looking at. But we can go ahead and do that. And let me just make sure. I think that, can't remember if we have to do something special if there is a, let's see, if there's multiple referencers. I don't think, yeah, we just put it all in a single function. So we can just copy that over. So that's good. What were the 2 that we left out here? Health check and instance group. Okay, so we have health check. And I'm guessing, let's see, spec.for-provider. Ooh, those are a slice. Okay, I'm actually going to come back and do this because that is a little different. So the things that, so we have backend service. Let's just go ahead and add network because we need that. Subnetwork. These can all be equals. All right. And this is subnetwork. And let's see. We have backend service already. Let's see. We'll want to make this subnetwork URL, which I believe is a thing. Yep. Make this subnetwork, network. Okay, that looks good. For provider subnetwork, and we'll update the subnetwork ref if it wasn't already populated. And were there any other ones here? Selector, well, let's just look for xpv1.reference. Target. So I'm guessing that the target is likely going to be, oh, and I'm gonna go ahead and make a note here also. This can reference multiple resource types. This is a hack for CAPI to ref the, and this might just be something where we actually have different fields for all of them. That would be one solution. I don't love that, and I don't think other people will either, but that might be the only option. We're also working on generic resource references, which means it wouldn't even matter. You would just use the field path to reference it. And we don't have a backend or a target TCP proxy URL yet, so we'll need to do that. Target ref. All right. Let's just go ahead and call it target TCP proxy URL because that's how it's actually going to be used. And once again, we're going to assume this uses the same URI schema as the other compute types. Let's see, index status. Oh, it just doesn't like that. That's okay. And this is where we want to use it. So once again, bit of a hack here, but it'll work for the time being. And okay, so that was forwarding rule. Let's take a quick look at what instance group and firewall look like. I feel like they're both going to be larger than the past two we've done. But let's just take a look. Instance group. Wow, much smaller than I was thinking. Yeah, wow, okay, this is very straightforward. Network, so that'll be a reference, subnetwork reference. Nice, okay, that is very small. It's encouraging. And firewall, is it just firewall or is it firewall rule? It's just firewall. Not bad, really not bad. Reference to network. Nice. Let's see how big this firewall out is. Not big at all. Okay. We could probably go ahead and knock this out if we wanted to. I need to get rid of all of these eventually. All All right, instance group, or should we go and see if we can disable the cluster API provider GCP? I really want to finish this up. So let's go ahead and do instance group and firewall real quick. I have confidence that we can knock them out really fast. Target TCP proxy type. Was this the small one? Yeah, okay. We'll reuse this one again. Get rid of these. And we'll find this and replace this with instance group. Oh. Oh, I did parameters. That would be why. I was a little confused there for a minute, but now that makes sense. Other declaration of instance group. Oh, instance group parameters. Sorry about that. Let's see. I'm going to take a look at my calendar here and make sure I have a block here to be able to keep going. Looks good. I know I mentioned last time the weather here has been hold on one second. Illegal cycle of instance group. Oh, there we go. Sorry about that. The weather here I'm in St. Louis, Missouri, has been a lot nicer recently, so I've been able to get back out and do some running. Although if anyone uses Strava, I use that and I run the same route every day because I'm kind of a creature of habit. But while it was extremely snowy here, there's another person who runs, apparently nearly the exact same route as me. And I believe that they kept running while it was super snowy. And I think I know who this person is because I see them out when I'm running sometimes. And so I lost my local legend or whatever they call it. I think that's the one for running. And it sent me a notification, and I could just only give that person respect because it was literally like feet of snow. I'm not sure how they even ran, but it was pretty impressive for sure. But anyway, all that to say, maybe I can win it back now that the weather's gotten a little nicer. All right, creation timestamp. And we'll need this named port type. All right, this is a very small one. And we're kind of lying to ourselves a little bit because there's going to be some modifications we're going to have to go back and make with these. But we might be able to still do a proof of concept relatively quickly with this, which is definitely really exciting. I'm really excited to show some of the upstream cluster API folks this. Because they have kind of like varying levels of familiarity with Crossplane, and I think this is going to be something that's really beneficial for a lot of people. So hopefully that is the case. Okay, and for network, I'm going to copy over our network ref from over here. Network ref. Okay, so let's bring this instance group types. And maybe I'll open this up in a PR just so folks can follow along because this is all local right now. And that will also be a nice thing to take a look at. Obviously, it will not be functional, but will help folks kind of put a name with a face if they're not able to attend the streams. Okay, so we're going to do the same thing that we did for target TCP proxy. And all we need here is to refactor target TCP proxy. I guess there's only one instance of that. To instance group here. Sorry about that. We're going to need to find one with network. Here we go. Awesome. So that was pretty straightforward. Okay. And gosh, that was a really fast one. I thought instance groups was, I was just associating it with instance, I think, and I thought it was going to be pretty cumbersome. But let's take a look at instance and see if it's even that bad. It could be a lot worse. I mean, there's let's see how much these have in them. Not really that much. Reservation affinity. Interesting. Accelerator config. Oh, that's kind of cool. Specify the full list. I'd love to look into the different accelerators that are available there. Okay, yeah, there's definitely some fields here for instance. So if we want to replace the GCP machine type, we'll have to look into that a little bit more. But for now, this works pretty good. Okay, and last one is firewall types.go. Instance group, I'm going to reuse this one because once again it was pretty small. And let's find instance group and we'll replace with firewall. And I think we said this one wasn't too big either, which would be really nice. Let's go ahead and copy this over. Target tags. Okay. Network. So we're going to have the same network ref selector kind of dance here. All right. Name we can get rid of. Firewall log config. We will need to pull in. Oh. Drop these into output only. Network ref. Okay, we already went through that. Destination ranges. Not sure why firewall denied isn't causing issues yet, but I'm sure it will. Oh, has to do with, I missed a, there we go. Here, now our errors are here. Firewall log config. Well, I guess we can start from the top. Firewall allowed. All right. This is probably going to look almost exactly the same to firewall denied. Okay. Yep. In fact, it's the exact same. We could probably just use the same struct for that, but I'll copy it over as they have it generated as that. Firewall log config. Okay, just one field, enable. Nice. Get rid of these. And let's see, firewall parameters, log config. Okay, this looks good to go. We do need to add our network referencer. Was that all that we said it referenced in the issue? References network. I guess so. All right, so let's update, and we can probably use our instance group one pretty much verbatim. All right, and let's see, firewall. All right, that was pretty easy. Okay, one of the things I forgot was registering all of these types. I'm gonna reuse backend service. So we need to do forwarding rule. Forwarding rule. I don't know why I just copied it that way. And we'll do forwarding rule. Okay. What were the other two? Forwarding rule, firewall, and instance group. Okay. Forwarding rule. And this was instance group. And this was, oh man, it always gets me with that. This was firewall. Awesome. Okay, forwarding rule, and we're gonna do instance group list. This one's gonna be firewall list and firewall. All right, and let's do our make generate, which is probably not gonna like because of our referencers having errors. Yeah, missing method get condition. Okay, let's go ahead and comment out our referencers for just a minute. Looks good. Awesome. Let's see. Pull this up again. Scroll down. And I bet if I close this and reopen it, it'll work okay. All right. Nice. Looks good. Only 54 files changed thus far. That's not related. Let's see. So we'll have to add all the types that we went through today. But we are well on our way. What is our go sum change? Oh, yeah, we need to clean that up. Okay, so we are well on our way, as I said, and we have all of our API types implemented. We're still going to need to go back and change some of them to pointer types and that sort of thing, but we've definitely made some really good progress on this. And so we have all of our types implemented, actually, which is definitely great to see. And I think that I'm going to go ahead and open up a pull request. And so that folks can follow it along, we'll just mark it as work in progress. Not sure why that's lowercase like that. And we'll go from there. Get status. Okay, so I don't want to add my creds, right, or my Prometheus.yaml yet. What do we have? APIs, examples, package, and the other package. Okay, get add APIs, examples, package. And we'll say add CAPI types for GCP cluster support. And we'll make this a whip, and that's okay because I'm going to unwind this commit anyway. So adds the required API types to support GCP cluster in cluster-api-provider-gcp. Okay, adds the required APIs to support GCP cluster and cluster-api-provider-gcp. And we'll just leave it at that for now because, and let me make sure we'll just add it as that for now. Like I said, we still need to implement these controllers, but they're going to be pretty boilerplate from some of the other ones. These resources we did today were also, in my opinion, a little bit less verbose than the other ones, which is really nice. So we're getting close to being able to do a actual POC that we could present, which is really nice. All right. So I'm going to go ahead and open this up, and this is going to fix 303 theoretically when it's done. And so we'll denote that. It's probably going to fail some linting and that sort of thing. Let's see. Fixes number 303. Those tests don't, well, there isn't really any tests yet. Actually, I'm just going to leave those uncommented because it's not really true in this case. Well, it's kind of true, but very much still a whip. I always do that. Okay. And we will make this a draft PR for now, and I'll denote some of the things that we need to do. To do, let's see, adjust, let's see, make optional fields pointer type for, I'll just say that in general, pointer types. We need to implement controllers for, implement clients first. Clients for backend service. I don't want to type these twice. For backend service, let's see, target, TCP, proxy, instance group. Wait, wasn't there a forwarding rule as well? Let's see. I've already forgotten what we did today. Router type, instance group, forwarding rule, yeah. Okay. It is helpful that we went mostly in order, though. backend service, target TCP proxy, forwarding rule, instance group, and firewall. Forwarding rule, instance group, firewall. So implement clients and controllers for those. Add unit tests for all clients and controllers. Let's see. We also need to implement update and late init for all API types. So still quite a bit of work to do, but we're definitely getting closer on this. And I'm glad that we at least have the APIs to work off of here to get a POC going. All right. Well, that is going to do it today. Like I said, we'll make this a draft pull request and go ahead and open that up. Just so folks can buy it, I'll make sure to drop a tweet linking to this so folks can kind of see some of the work around this. Yeah, and then we can go from there. And yeah, thanks for tuning in today, folks who watched, and hopefully this will be a resource for some other folks as well. We'll continue to plug away at this. I think, you know, towards the end of this week, beginning of next week, we do have a Crossplane release coming out, but getting this out the door is definitely a high priority, and we want to show it off. So if you're interested in helping out also, please feel free to jump in. But yeah, with that, we'll go ahead and sign off and